Alright, grade 12. So this video is about trig triangles in 3 dimensions. Please make sure you've watched the other little video snippet of me explaining horizontal and vertical planes before you watch this, or have a look in your textbook at page 183, 184, around there, where it also explains the definitions. Also page 186 in your textbook. So page 186 is really handy. This that I'm doing now with you is on page 187 going to 188 from your textbook. So you are able to get it from there. All right, so they tell you here in the following sketch, AC is a vertical line. So AC is vertical. This vertical is implying that we're going to have perpendicular situations there. So the first thing I'm going to do is actually draw out this ACB on this side with a 90 degrees. And ACD on that side with a 90 degrees. All right. BCD lies in a horizontal plane. So this piece here, if we talk about it being the horizontal plane, it's flat on the floor. Right. Then they tell you that BD is 10 meters. CBD over here is 40. And we have 60 over here. And the angle of elevation from A from B is 48 degrees there, and the angle of elevation of A from D is alpha. So they've given you that bit of information. All right, so now they say calculate the length of AB. So AB is the hypotenuse of this triangle. So we have 48 there. Now, in order to work out the hypotenuse, you either need to be able to use opposite over hypotenuse, adjacent over hypotenuse, or Pythag. But we can't use Pythag because we don't even have any sides, never mind 2 sides out of the 3. So the best thing is to be able to try use adjacent over hypotenuse. So if we can find BC, that would be handy. So now talking about that, let's just go to the top here. Please have a look at this now. It says, when solving problems involving triangles in different planes, always look for a common side between the triangles containing the side or angle you are required to calculate and another triangle. Start by calculating the common side. So BC is what I like to call a link side. So it links the 2 triangles, and the majority of the information is in that green horizontal plane triangle, BCD. So we want to work with that one first. So we're going to work out BC first and then come back to AB. All right, so let's start with A1. We're going to say in triangle BCD, angle BCD is equal to 80 degrees. This one over here. Right, because of angles of a triangle. Right, so now that I've got everything in that triangle, let's work with trying to find BC. So let's look. BC is opposite 60 degrees. 10 is opposite the 80. I can't use the 40 because across from it is CD, which I don't have. So I'm going to work out BC over sine 60 is equal to 10 over sine 80. All right, so then BC by itself is sine 60 over sine 80, and that's going to get you 8,79 meters. All right, please make sure that you do give us the reason there, angles of a triangle. Don't just go into using the angle. Then AC. So let's just fill in BC here is that. Sorry, not AC. AB is our hypotenuse. So we now have our adjacent. This is our adjacent. Right? We need our hypotenuse. So we can use cos. So cos of 48 degrees is going to be equal to my adjacent over my hypotenuse. So to rework this, it's going to be 8,79 divided by cos 48, which is going to get us 13,14 meters. All right. Then we can fill that in on our diagram. 13,14. We can do it on the big one as well. And that's 8,79. Always just keep filling in everything that you see. All right, what I'm also seeing here is that we do have a right angle triangle. I can work that out to be 42 degrees. Okay. So then now we've got to work out AC. So AC is the vertical line in this triangle here. So we can use opposite over adjacent, opposite over hypotenuse, whatever you want. I'd prefer opposite over adjacent, so tan of 48, just because then I'm only working with one number that I've already worked out, whereas the 13,14 is a working out after a working out. So AC over opposite over adjacent. So AC is going to be equal to 9,76 meters. 9,76 meters. So that can go on all of your diagrams that have AC on it. All right, then last one is AD. So AD is in the right-hand side of the diagram, and we've only got alpha, so we've got one side, an unknown angle. We've got nothing in that top corner with A. We've got 90 degrees. So we need to use some extra information. So we've got to work with the link side, CD. All right, so CD in the bottom triangle, we can work that out. So CD is across from sine 40. And then we can use our 10 over sine 80 again. So CD is 10 sine 40 over sine 80, which gets us 6,53 meters. All right, so we've got 6,53 meters. And then now we've got two sides in a right angle triangle. We can use Pythagoras to find the third side. So AD squared is going to be equal to 6,53 squared plus 9,76 squared. So AD squared is going to be 137,8985. So AD is 11,74 meters. All right. So we've got that now, 11,74 meters. Okay, so then in the next question for B, they ask us to work out the size of angle alpha. So alpha is in this triangle ACD. So we've got it here, ACD. We know 9,76, 6,53, and 11,74. Alpha's here. You can take your pick on what you want to work with. Opposite over adjacent, opposite over hypotenuse. I like working with tan, so tan alpha is equal to opposite over adjacent. So alpha ends up being 56,22 degrees. So in your calculator, you say shift tan of that fraction, and your calculator will give it to you. All right. All right, the next one is calculate or write down the angle of depression of B from A. So they told us the angle of elevation of A from B is 48 degrees. So the angle of depression of B from A will also be 48 degrees. And that's because the angle of elevation, so let's just draw this out again, it's 48. That's to a horizontal. So we're working BC as a perfect horizontal. And so we dot in a perfect horizontal. Those lines are parallel, so that's 48 degrees. Or having a look that this is 42 degrees, they add up to make 90 there. All right, so the angle of depression of B from A is also 48 degrees. Then for question D. D is a bit tricky because you're inclined to want to just jump for a quick answer. D, they don't have mark allocations here, but D would be worth a good like 4 marks. So it's not as obvious as it seems. So it says calculate the angle of ABD. Now they don't want you to just take 48 and 40 and add them together, because understand this is a perspective drawing. They want you to imagine that angle ABD is completely flattened out now, and so we need to work with the full triangle here, ABD. So when we're trying to work out an angle and we have 3 sides, so if this is ABD, this is 13,14, 10, and 11,74, and we want to work out ABD, we're going to use the cosine rule. All right, so let's just erase some of this stuff. All right, so we're going to use the cosine rule. Where we're going to say we need B, so the opposite of B is 11,74 all squared, and then we know we're going to have cos B on the end. All right, so the opposite side to the angle that you're looking at are opposite on the cosine formula. So then the other 2 sides, we add them together and square them, and minus 2 times each of the sides. And then all we've got to do is rearrange to get cos B by itself. So I like to just take these 2 across and then divide by that coefficient of cos B. Right, so it becomes 11,74 squared minus 13,14 squared minus 10 squared, all divided by -2 times 13,14 times 10 is equal to cos B. So you're going to work out this left-hand side in your calculator and then keep the answer there and say shift cos in your calculator. And that gets you to 59,13 degrees. Right, so angle ABD is 59,13 degrees. Okay, and then the last one, they want you to work out the area of triangle ABD. Well, now we've got the side, our angle, and another side. We can use our sine area rule. So the area of triangle ABD is equal to half of 13,13 times 10 times sine of the included angle. Right, so please remember it has to be an included, so side, angle, side. And then that gets us to 56,39 square meters. I know it's a triangle, but because we're working with 2 sides, 2 dimensions, it becomes squared, always area squared. All right, so we are going to be moving on in the next video to the variable type. So you can now practice from this type questions from exercise 1 on page 189. So page 189, there is exercise 1. And if you're working in the little sample textbook that we gave you, I think it's page 86. And nice ones to do there are questions A and questions D. We will go through the answers in class, but those are suitable ones to practice so long. And then the variable ones, there'll be slightly more examples to work on, more in the exercise to work on, and that exercise is exercise 2 later on in the textbook.